Good afternoon. Today I am going to discuss one new topic called as the ANOVA. ANOVA means analysis of variance. So it is an overall structured test, and also it is called as a statistical test which is used for testing the null hypothesis for more than two population means. So here what is the difference between t-test as well as this ANOVA test means? T-test, it is only suitable for testing only the two sample means. So if it is more than two sample means or two population means, then you go for this analysis of variance, that is ANOVA test. So here when the data or when the input data or when the given data is to be a given quantitative data, then test the null hypothesis for this more than two population means, then you can go for new procedure which is called as an analysis of variance test. So in this ANOVA test, it consists of three types. One is a one factor ANOVA and two factor ANOVA and ANOVA for repeated measures. So one factor means, so in this one factor, it consists of only one dependent variable as well as only one independent variable. So here you have to calculate the difference that exists between the population means. So based on one independent variable means, the ANOVA test is called as a one factor ANOVA. So here two factor means, here the difference that is calculated or the statistical test that is performed on this one. So the difference that is calculated among the two population means based on the two independent variables means, this is called as a two factor ANOVA. So here repeated measures means the population means that the values are repeatedly used at the same time means, here you go for the new procedure that is called ANOVA for repeated measures. So the next one is the statistical hypothesis. So how to represent the statistical hypothesis for this population means, so here we are using more than two population means. So you can write the null hypothesis. So here in the statistical hypothesis, we have to represent two hypotheses. One is a null hypothesis, another one is the alternate hypothesis. Null hypothesis represented as H0. So the H0 that can be represented as H0 colon mu0 equal to mu24 equal to mu48. Here these are mu0 and mu24 as well as mu48 is also called as a population means, and alternate hypothesis which can be represented as H1. So then you can write simply as H0 is false. So here one factor ANOVA, already we discussed one factor ANOVA definition. So one factor means, so here it contains only one dependent variable and another one is only one independent variable. So here you have to perform the statistical test for this data. So for more than two population means, based on one independent variable means, that factor that type of ANOVA is called as a one factor ANOVA. So under this one you are going to calculate the three things. One is the difference between group means, and variability within groups, and variability between groups. So here difference between group means it is also called as a treatment effect. So the existence of at least one difference between the population means defined by the independent variables means, that is called a treatment effect. So the variability within groups defined as variability among the scores of subjects who in being same group receive the same experimental group means, it is called variability within groups. And the next one is variability between groups. Here the variability among scores of subjects who being in different groups receive different experimental treatments means, it is called variability between groups. So in this process, here we are calculating the F test. So for one factor ANOVA, there is two F tests are calculated. So F test means it is a ratio between variability between groups and variability within groups. So here the F test is calculated based on the random error. So based on, and also based on the hypothesis, statistical hypothesis. If the null hypothesis is true means, here it generates the random error both in this one. So F is equal to, F is represented as F is equal to random error by random error. So the values in around between 1 only. So if the null hypothesis is false means, so that can be represented as F is equal to random error plus treatment effect divided by random error. So we go for the definition formula. So one factor ANOVA contains the two types of formulas. One is the definition formula, another one is the computation formula. So before that you have to know definition formula, variance. So under this one, variance estimate. So variance means it defines the sample variance that measures the variability between the groups as well as within the groups. So the variance, sample variance that can be calculated or measured by using sum of squares. So the sum of squares, which is represented as SS. So in formula, SS is equal to summation of x minus x bar the whole square. So in other terms, S square is equal to SS divided by n minus 1. S is nothing but it is a sample variance. So n minus 1 is also called as a degrees of freedom, which is also represented as S square is equal to SS divided by NF. So this is the sample variance. And the next one is degree of freedom. So already you know no? Degree of freedom. So it is nothing but in the numerator, we have number of deviations that can be. So you have to represent how many deviations are there in the numerator part. So that is a degree of freedom means that is feel free to vary in that one. So here that is represented as df. So df value is equal to n minus 1. So this is the degrees of freedom. Next is the mean square value. So the mean square is one of the variance estimates calculation only. So it is calculated by sum of squares divided by degrees of freedom. Next we continue with the computational formula. Okay, commutation formula means which is very simple to calculate or for computation purpose. So here first in this one factor ANOVA, first we have to calculate the total sum of squares. So here that is represented as SS total. So the SS total is equal to summation x square minus g square divided by n. G means it is a grand total and n means number of population. So next you have to calculate for the between sum of groups. So SS between is equal to summation t square divided by n minus g square divided by n. T means it is a column total. Okay. N means number of samples and G means it is a total value and total number of population. And for the within sum of squares, SS within that can be represented as summation x square minus summation t square divided by n. And finally, if you want to check the accuracy, you can go for one more formula. So SS total is equal to SS between plus SS within. Okay. So the next part is the degree of freedom. So which is represented as df. So here also calculates df total. So df total we can represent n minus 1. So n is the total population value minus 1 and df within df between. So df within formula is n minus capital N minus k and between means k minus 1. K means that is the number of columns. So within means capital N minus K, and DF between means K minus 1. And if you want to here also you can check that is DF between. Check here. This is the formula for sum of squares for accuracy checking. And next you have to write the formula for mean square values, MS value. So mean square means it is represented as MS. Already you know the ratio between the SS divided by degree of freedom. So here MS between, which is equal to SS between divided by DF between. And MS within is equal to SS within divided by DF within. Finally, I have to go for the F test calculation part. So F test is equal to F ratio, which is equal to, it's a ratio between the variability, that is mean square between as well as mean square within. So MS between divided by MS within. This is a final F ratio formula. Next we continue with the one problem. So this is the question. So a psychologist test whether a series of workshops and assertive training increases eye contacts initiated by the psychology students. A total of 32 subjects are randomly assigned, 8 to a group to attend either 0, 1, 2 or 3 sessions. So this is the sessions. 0 session, here the 8 values are assigned to each group. So for a 0 group, 8 values are assigned. For 1 group, 8 values are assigned. And 2 group, 8 values are assigned. And 3 group, 8 values are assigned. So they asked to calculate test the hypothesis at 0.05 level of significance and also summarize the ANOVA table. Okay, so from the question, so total amount of what is the grand population, okay, that is represented as n. So the total values are 8, so total are 32 subjects. So n value is n is equal to 32, okay. So from that you have to calculate all these formulas, okay. So total sum of, first you have to calculate total sum of squares. So SS total, SS between, SS within, and next you have to calculate degrees of freedom, and next you have to calculate the mean square values. So first just start with the computation, I mean sum of squares value. So already from the table the n value, the n is equal to, capital N is equal to 32, okay. So next you have to calculate the x square value, x value, okay, and the g value. So total number of values, okay. For this, the first step is research problem. So on average, are the number of eye contacts initiated by the number of eye contacts initiated by psychology students affected when they attend either 0, 1, 2 or 3 sessions. Sessions on training. Okay, so first you have to, that is the first step, you have to write the research problem. So for this question, so you have to first write on average the number of eye contacts initiated by the psychology students affected when they attend either 0, 1, 2 or 3 workshop sessions on assertive training. Okay, the next step is statistical hypothesis. So here from this problem, there is more than 2 population means are represented. Totally 4 population means are represented. So here, which is represented as H0, so mu 0, which is equal to mu 1, which is equal to mu 2, which is equal to mu 3. Okay, so automatically the H1 can be written as H0 as false. This is statistical hypothesis. And the next step is decision rule. Okay, so the decision rule can be written as reject H0 at the 0.05 level of significance is given at 0.05 level of significance if the critical F value or the calculated value is greater than or equal to the critical F value. So the value is calculated in between the DF between is equal to 3 and DF within equal to 28. So here the value is, the critical value is nothing but it is a tabulated value. Okay. So if the calculated value is greater than or greater than the calculated, I mean tabulated value means automatically the null hypothesis is rejected and the alternate hypothesis retained. And the fourth one is the calculation part, that is a F calculation. Okay. So already given the problem. So 8 values are assigned for each population. Okay, ma? So for 0 population, 8 values are assigned. For 1 population, 8 values are assigned. For 2 population, 8 values are assigned. And the 3 population, 8 values are assigned. So from this, you have to first calculate the group total. So for this group total, so the value is 13. For this value is 25. And for this value is 40. And for this value is 60. So the grand total is G is represented as 138. Okay. So the given data N is equal to 32. The grand total G is equal to 138. And the T, that is a column total, is equal to 13, 25, 40 as well as 60. So you can start with the first sum of square process. So first you have to calculate the total sum of squares. So SS total, the formula is equal to summation T square divided by N minus G square divided by capital N. So already you know the T square value, T value. Okay, va? So you can write T square, 13 square divided by 8. So 8 means number of values in the each column, that is 8. So that is small n is equal to 8. So plus 25 square divided by 8 plus 40 square divided by 8 plus 60 square divided by 8 minus, what is the G square value? That is 138. So 138 square divided by capital N value is 32. This is the first concept. Okay, ma? So here, if you have calculated means you will get the value as 169 plus 625 plus 1600 plus 3600 divided by 8 minus 595.125. So you will get the answer SS total is equal to So initially the N value is given, N is equal to 32, G is equal to 138, T is equal to 13, 25 as well as 40 and 60. T means it is a column total. Okay. First you are going to calculate the sum of squares between. Okay, va? So between the values. So the formula is represented as SS between, which is equal to summation T square divided by N minus G square divided by N. So you have to give all the values of T, column total, 13 square divided by 8 plus 25 square divided by 8 plus 40 square divided by 8 plus 60 square divided by 8 minus 138 square divided by 32. So you have to square all the values and divided by 8 minus 138 square divided by 32. So we will get the value as SS between is equal to 154.125. This is SS between. Next you can calculate SS within. So SS within is equal to summation x square minus t square divided summation t square divided by n. So in this part you want to calculate the x square value and also already you calculate the summation t square value, right? So you can directly apply. So summation x square value is, so you have to square up all the 32 values. Okay, so like that. 1 square plus 0 square plus 0 square plus 2 square plus 3 square plus 4 square plus 2 square plus 1 square. So that same 2 square plus 1 square plus 2 square plus 4 square plus 4 square plus 6 square plus 3 square plus 3 square plus 4 square plus 2 square plus 3 square plus 6 square plus 7 square plus 8 square plus 5 square plus 5 square. 7 square plus 1 square plus 6 square plus 9 square plus 10 square plus 12 square plus 8 square plus 7 square minus this value. Okay, so from that you will get 749.25. Okay, va? So the next S is within is equal to 882 minus 749.25. So which is equal to 132.75. So this is S is within value. Okay. Next you go for the total value. S is total. So total is equal to summation x square minus g square divided by n. Already you calculated the x square value, that is 882 minus g square 595.125. So which is equal to 286.87. So this is S total. So if you want to check check for accuracy means you can calculate SS total is equal to SS between plus SS within. So SS between value is equal to 154.125 plus 132.75. Then you will get 286.87. Okay. The next one is you have to calculate the degrees of freedom. So df total is equal to capital N minus 1, which is equal to 32 minus 1 equal to 31. So df between, so which is equal to k minus 1. So k means number of columns. Here 4 columns are there. 4 minus 1 is equal to 3. And df within is equal to capital N minus k. So 31 minus k value is 4. So 27. So check for accuracy. df total is equal to df within plus df between. So which is equal to within value is 27 plus 3, which is equal to 31. This is df total. You will get the correct answer. Okay. The next step, how to calculate the mean square value. Mean square ms value. So ms between value, the formula is SS between divided by degrees of freedom. So df between. So already you know the values. So what is the SS between value? 154.25 divided by DF between value, DF between, that is 3. Okay, so the answer is 51.37. And next is MS within. So here which is equal to SS within divided by 27. Yeah, sorry. DF within. So SS within means SS within value is 132.75 divided by 27. Sorry, 28. Right. 28. So the answer is 4.74. This is MS within. Okay. Now you got MS value, that is MS between as well as MS within. Now you can calculate F ratio value. So F is equal to MS between divided ratio between MS between and MS within value. So MS between value is 51.37 divided by 4.74. So F is equal to 10.84. So F value is greater than so here this is a FLE, calculated FLE. The next step is decision. So the another you can reject or retain the H0. You can reject H0 since F calculated value, okay, which is equal to 10.84, which is greater than is F critical value. That means tabulated value. Okay, that is 2.9. Automatically, you can reject the null. It's affected by attending at either 0, 1, 2, or 3 sessions of an assertive workshop sessions. Okay. These are all the steps to calculate the one factor ANOVA. So just to recap the steps. So first you have to get the data from the questions. Okay, here there are more than 2 population means are there. Totally 4 population means are there, 0, 1, 2 as well as 3. So you go for the one factor ANOVA. So first step is you have to write the research problem, and the next step is you have to write the statistical hypothesis, and the next step you have to write the decision rule, and then the next step you have to go for the calculation process. In the calculation process, first you have to calculate, the first step is sum of squares. So sum of squares for total values as well as sum of squares for between values as well as sum of square for within values. So first once if you get the values, next you go for the degrees of freedom calculation. So DF total, DF between as well as DF within. DF total is equal to n minus 1, DF between is equal to k minus 1, and DF within is equal to n minus k. So once the calculation process is over, then you go for the next step, that is to calculate the mean square values. So the mean square only you have to calculate for between as well as within. So MS between is equal to SS between divided by DF between, and MS within is equal to SS within divided by DF within. So finally you will get the answers. So MS between value as well as MS within value. Next in the last step is you go for the F ratio calculation. So F means F ratio is a ratio between value as well as the within value. So MS between divided by MS within. So you have to apply the or substitute the values of MS between value as well as MS within value. MS between value in numerator, MS within value in denominator. Then you will get a value as F ratio value. F is equal to 10.84. The next step is you have to go for the decision. So here the calculated value is, it is always greater than the tabulated value. So automatically here the null hypothesis is rejected. So finally you have to write the interpretation process. Thank you.